Okay. Good morning, students. Let us continue the discussion regarding chemical kinetics. In the last class, we have started the discussion regarding the temperature dependence of rate of reaction. Okay. If temperature increases, rate constant also increases. Therefore, rate also increases. Okay. Almost, if you increase the temperature, number of total collisions per unit volume will not increase, but only with increase in temperature, effective collisions increases. Please remember this point. With increase in temperature, total number of collisions will not increase, but effective collisions, number of effective collisions increases. Only the effective collisions brings about the product formation. With increase in temperature, we can increase the number of effective collisions per unit volume of the reacting medium. Whenever effective collisions increases, product formation also increases. This happens with increase in temperature. One ಅರ್ಥ ಮಾಡ್ಕೊಳ್ಳಿ, ನಾನು ಹೇಳಿದ್ದೇನಪ್ಪ ಅಂದ್ರೆ ಟೋಟಲ್ ಕೊಲಿಷನ್ಸ್ ಜಾಸ್ತಿ ಆಗೋದಿಲ್ಲ ಟೆಂಪರೇಚರ್ ಜಾಸ್ತಿ ಮಾಡಿದಾಗ. 100 ಮಾಲಿಕ್ಯೂಲ್ಸ್ ಅದಾವ, 100 ಮಾಲಿಕ್ಯೂಲ್ಸ್ ಕೊಲೈಡ್ ಆಗ್ತಿರ್ತಾವೆ. ಮುಂಚೆನು ಈ ಟೆಂಪರೇಚರ್ 10 ಡಿಗ್ರಿ ಇತ್ತು, ಈಗ 20 ಡಿಗ್ರಿ ಮಾಡ್ಕೋ. ಏನಾಗ್ತದೆ, ಫಸ್ಟಿಗೆ 100 ಔಟ್ ಆಫ್ 100 ಒಳಗೆ 60 ಕೊಲೈಡ್ ಆಗ್ತಾ ಇದ್ವು ಅನ್ಕೋ. ಎಕ್ಸಾಂಪಲ್ 60 ಕೊಲೈಡ್ ಆಗ್ತಾ ಇದ್ವು. ಈ ಟೆಂಪರೇಚರ್ ರೈಸ್ ಮಾಡಿದಾಗ ಏನಾಗ್ತದೆ, 60 ಇದ್ದು 70 ಆಗ್ಬೋದು, 80 ಆಗ್ಬೋದು, ಡಿಪೆಂಡಿಂಗ್ ಅಪಾನ್ ದ ನೇಚರ್. ನಂಬರ್ ಆಫ್ ಎಫೆಕ್ಟಿವ್ ಕೊಲಿಷನ್ ಜಾಸ್ತಿ ಆಗ್ತದೆ. ಎಷ್ಟು ಎಫೆಕ್ಟಿವ್ ಕೊಲಿಷನ್ಸ್ ಇರುತ್ತೋ ಅಷ್ಟು ಪ್ರಾಡಕ್ಟ್ ಫಾರ್ಮೇಷನ್ ಬರ್ತದೆ. ವಿತ್ ಇನ್ಕ್ರೀಸ್ ಇನ್ ಟೆಂಪರೇಚರ್ ಯು ಕ್ಯಾನ್ ಇನ್ಕ್ರೀಸ್ ದ ನಂಬರ್ ಆಫ್ ಎಫೆಕ್ಟಿವ್ ಕೊಲಿಷನ್ಸ್, then rate constant also increases automatically. If rate constant increase, rate of reaction also increase. Now let us discuss about the activation energy concept here. Activation energy. It is indicated by symbol EA. What is activation energy? It is the minimum energy required for the molecules to form the intermediate called activated complex. Okay? The molecules which undergo effective collisions, they should possess some minimum energy. Then only intermediate or activated complex will be formed. Okay? The amount of energy, the minimum energy required for the molecules to form the intermediate or activated complex is called as activation energy. Activation energy ಏನಂದ್ರೆ ಒಂದು ಮಾಲಿಕ್ಯೂಲ್ ಒಂದು ಮಿನಿಮಮ್ ಎನರ್ಜಿನ ಹೊಂದಬೇಕಲ್ಲ, ಅದಕ್ಕೆ ಇಂಟರ್ಮೀಡಿಯೇಟ್ ಫಾರ್ಮೇಷನ್ ಮಾಡಕ್ಕೆ ಹಿಂದೆ ಡಯಾಗ್ರಾಮ್ ತೋರಿಸಿದ್ದೆ. This is what activated complex. This is energy of reactant, this position, this energy gap look at here. This is what activation energy. ಇಲ್ಲಿಂದ ಎನರ್ಜಿ ಇಷ್ಟ ಐತಿ, ಇಷ್ಟ ಆಗಬೇಕಲ್ಲ, ಇಲ್ಲಿ ಎನರ್ಜಿ ಗ್ಯಾಪ್ ಐತಲ್ಲ, ಅದೇ ಏನು activation energy. The minimum energy required for the molecules to form the activated complex is called as activation energy. Okay? Under activation energy ಬಗ್ಗೆ ಡಿಸ್ಕಷನ್ ಮಾಡಿದ್ವಿ ನಾವು ಈಗ. Now let us discuss about the Arrhenius equation. Arrhenius equation. Let us study about Arrhenius equation. Arrhenius ಏನು ಮಾಡ್ದಂಗಂದ್ರೆ he has given a mathematical expression which relates the rate constant K and activation energy A and one more thing, temperature. He has related these all three things in one expression. ಈ ಮೂರನ್ನು ರಿಲೇಟ್ ಮಾಡ್ತಾನೆ. ಏನನ್ನ ರೇಟ್ ಕಾನ್ಸ್ಟಂಟ್ ಅನ್ನು ರಿಲೇಟ್ ಮಾಡ್ತಾನೆ, activation energy relate madana. Activation energy is also known as energy of activation. Activation energy andru onda, energy of activation andru onda, ಮತ್ತು temperature. One more thing is temperature. ಮೂರು ಅದರೊಳಗೆ ಬರ್ತಾವಲ್ಲ. ಹಂಗಾರೆ ಎಕ್ಸ್ಪ್ರೆಷನ್ ಏನಾಗಿತ್ತು ಅದು ನೋಡೋಣ. The Arrhenius equation is this is that equation. K is equal to A into e to the power minus EA divided by R into T. This is what? Arrhenius equation. Okay, this is Arrhenius equation. Now, let us discuss about one by one. What is K? Rate constant. You already know about this one. Rate constant. What is A? This is known as Arrhenius factor. Arrhenius factor. Arrhenius factor, or it is also called as Arrhenius frequency. Okay, it means this is total number of collisions. It explains about total number of collisions per unit volume of the reacting medium per second. Total number of collisions ಎಷ್ಟಾಗ್ತಾವು ಒಂದು ಸೆಕೆಂಡಿಗೆ ಒಂದು ಯೂನಿಟ್ ವಾಲ್ಯೂಮ್ ಒಳಗೆ ಅನ್ನೋದು ಎ ಆಗಿರುತ್ತೆ. ಇಟ್ ಇಸ್ ಆಲ್ವೇಸ್ ಕಾನ್ಸ್ಟೆಂಟ್. ನಾನು ಹೇಳಿದ ಎಕ್ಸಾಂಪಲ್ 100 ಮಾಲಿಕ್ಯೂಲ್ಸ್ ಇರ್ತಾವೆ. 100 ಮಾಲಿಕ್ಯೂಲ್ಸ್ ಒಂದಕ್ಕೊಂದು ಕೊಲೈಡ್ ಆಗ್ತಾವಂದ್ರೆ ನಮಗೆ ಟೋಟಲ್ ಕೊಲಿಷನ್ಸ್ ಎಷ್ಟಾಯ್ತು 100 ಆಗ್ತಂದ್ರೆ ಅದು ಕಾನ್ಸ್ಟೆಂಟ್. ದಟ್ ಈಸ್ ಅರೇನಿಯಸ್ ಫ್ಯಾಕ್ಟರ್. ಇಟ್ ಎಕ್ಸ್ಪ್ಲೇನ್ಸ್ ಅಬೌಟ್ ಟೋಟಲ್ ನಂಬರ್ ಆಫ್ ಕೊಲಿಷನ್ಸ್. ಓಕೆ, ವಾಟ್ ಈಸ್ ಇ ಎ? ಆಲ್ರೆಡಿ ನೋ ಅಬೌಟ್ ಆಕ್ಟಿವೇಷನ್ ಎನರ್ಜಿ. ಇ ಎ ಇಸ್ activation energy. It is activation energy. R is what? Gas constant. R is gas constant. Already you know about its value 8.314 joule per Kelvin per mole. First piece states of matter kaltiralla R value idu standard value 8.314 joule per Kelvin per mole. Next, we have discussed A, EA and R. Now T is temperature. T is what? Temperature at which the reaction is taking place. But the important thing is, what is this one? This was to A. Total agide ಏನು? This is what? This is number of molecules. Number of molecules equal to or more than activation energy. ಇಷ್ಟು ಮಾಲಿಕ್ಯೂಲ್ಗಳಿಗೆ ಏನೈತಿ ಆಕ್ಟಿವೇಶನ್ ಎನರ್ಜಿ ಎಷ್ಟು ಇರಬೇಕು ಅಷ್ಟು ಐತಂತ ಪ್ರಾಡಕ್ಟ್ ಫಾರ್ಮೇಷನ್ ಆಗಕ್ಕೆ. ಹೇಳಿದ್ರೆ ಆಗಲ್ಲ. ಔಟ್ ಆಫ್ 100 60 molecules are possessing some minimum energy to form the products. Okay, that number is represented by this whole term e to the power minus EA divided by RT. This is number of molecules equal to or more than activation energy. The number of molecules with equal to or more than activation energy. If A ನಲ್ಲಿ ಎಷ್ಟು molecules ಇರಲ್ಲ ಅವಷ್ಟು ಪ್ರಾಡಕ್ಟ್ ಫಾರ್ಮೇಷನ್ ಮಾಡೋದಿಲ್ಲ. ಬಟ್ molecules which are represented by this whole term will form the product. A ಎಷ್ಟೈತಲ್ಲ ಅವಷ್ಟು ಪ್ರಾಡಕ್ಟ್ ಫಾರ್ಮೇಷನ್ ಮಾಡೋದಿಲ್ಲ. ಆದರೆ ಈ molecules they will form the product formation. Okay, now let us assume, let us consider here once again consider this equation. What it is? K equal to A to the power minus EA divided by R into T. Let this be equation number 1 and equation number 190. Okay. Now, taking logarithm on both sides. Taking logarithm on both sides. Okay. If you apply the logarithm, you can take the ln also. Ln is the log again convert ಮಾಡ್ಕೊಳ್ಬೇಕು. Okay. Then it is equated as ln k is equal to ln a into e to the power minus ea divided by r into t. Okay. In which form it is present? Log of a into b. It is present in the form of log of a into b. Formula ready. Okay. Log a into b na ಏನು ಬರೀತೀವಿ ನಾವು? Log a into b ಇದ್ರೆ ಏನಂತ ಬರೀತೀವಿ? Log a plus log b ಬರೀತೀವಿ. Okay. Log a plus log b formula ಬರೀತೀವಿ. This is written as ln k is equal to ln a plus what? Ln e to the power minus ea divided by r into t. ಯಾಕೆ ಹೀಗೆ? Because it is in the form of log m into n. It is written as log m plus log n. ಈ ಫಾರ್ಮುಲಾ ಅಪ್ಲೈ ಮಾಡಬೇಕು. ಅದಕ್ಕಾಗಿ ಇದು ಬಂತು. Okay. This is the formula. Okay. ಈ ಫಾರ್ಮುಲಾ ಒಂದು ಸಂಜೆ ಈಗ. Now ln k is equal to, look at it, ln k is equal to ln a minus of ea divided by r into t, minus ea divided by r into t. Why? See that. In which form it is present now? In which form it is present? See that. It is present in form of ln m to the power n. It is in the form of log m to the power n. ಈ ರೀತಿ ಇದ್ರೆ ಏನಂತ ಬರೀತೀನಿ ನಾನು? n into log m form ನ ಬರೀತೀನಿ ನಾನು. n into log m form ನ ಬರೀತೀನಿ. Okay. And one more thing. Here I want to write you one thing. Ln e is equal to 1. If nothing is there, to the base 10 is there. Even number 10 is the log ruler. Okay. Ln e ಅಂತಂದ್ರೆ 1 ಅಂತ ಅರ್ಥ. Ln e means what? 1. ಅಲ್ಲಿ 1 ಬಂತು. ಅಂದ್ರೆ 1 into this whole term remains as it is. Ln e ಹೋಗ್ಬಿಡುತ್ತೆ ಅಲ್ಲಿಗೆ. ಹೌದಾ? ಈ ಫಾರ್ಮುಲಾ ಬಂತಂದ್ರೆ ಈಗ ಗೊತ್ತಾಗ್ತದೆ? Any doubts here? Log of formula apply ಮಾಡಿದ್ರೆ ನಾನು ಅಷ್ಟೇ ಮತ್ತೇನಿಲ್ಲ ಅನ್ಸಲ್ಲ. Okay. Now simplify this one. Ln k is equal to, if I take rearrange this one, what happens? Minus ea divided by r into t plus ln a. Ln a is the formula. Let this be equation number 2. Simplify ಮಾಡೋಣ. ಗೊತ್ತಾಯ್ತಂದ್ರೆ rearrange ಮಾಡಿದೆ. ಇಲ್ಲಿ ಪ್ಲಸ್ ಇತ್ತು, ಈ ಕಡೆ ಪ್ಲಸ್ ತಗೊಂಡೆ, ಇದು ಮೈನಸ್ ಇತ್ತು, ಮೈನಸ್ ಈ ಕಡೆ ತಗೊಂಡೆ ನಾನು. a plus b ಅಂದ್ರು ಒಂದ, b plus a ಅಂದ್ರು ಒಂದ. rearrange ಮಾಡ್ಕೊಂಡೆ ನಾನು ಅಷ್ಟೇ, ಮತ್ತೆ ಮಾಡಿಲ್ಲ. Okay. Now what is coming here? Ln k is equal to minus a divided by rt plus ln a. Let this be equation number 2. At temperature T1, ln K1 is equal to minus EA divided by R into T1. At temperature T1, rate constant is K1 plus ln A. Let this be equation number 3. Let this be equation number 3. At temperature T2 at temperature T2, what happens? Then K2 is equal to minus EA divided by R into T2 plus ln A. That is the equation number 4. This is the rate constant equation at temperature T2. This is the rate constant equation at temperature T1. Okay? Here are temperature normal. Always T1 is greater than the T2. T2 T1 के temperature जास्ती होता है. Now, subtracting equation 4 by equation number 3. Equation number 4 and 3 वाला minus 1. Sorry, 4 and 3 वाला minus 1. See here. What is equation number 4? Ln K2 minus ln K1 is equal to minus EA divided by R into T2 plus ln D. This is equation number 4. Minus equation number 3. See here minus into minus. Here already minus is there. Take again minus. Subtract minus into minus, what happens? Plus EA divided by R into T1. R into T1. This plus ln A becomes minus ln A. Minus ln A. Plus ln A minus ln A. Gets cancelled. It means total number of molecules are not important in increasing the rate constant with increasing temperature. Total number of molecules go and the total number of collisions go, rate increase agadu ಯಾವುದೇ ರಿಲೇಷನ್ ಇಲ್ಲ. ಯಾಕಂದ್ರೆ ಏನೋದೇನೋ ಟೋಟಲ್ ನಂಬರ್ ಆಫ್ ಕೊಲಿಷನ್ಸ್ ಅದಕ್ಕೂ ಇದಕ್ಕೂ ಸಂಬಂಧ ಇಲ್ಲ. ರೇಟ್ ಕಾನ್ಸ್ಟೆಂಟ್ಗೂ ಮತ್ತು ಟೋಟಲ್ ನಂಬರ್ ಆಫ್ ಕೊಲಿಷನ್ಸ್ಗೂ ಯಾವುದೇ ರಿಲೇಷನ್ ಇಲ್ಲ. ಯಾಕಂದ್ರೆ ಕ್ಯಾನ್ಸಲ್ ಆಗಿಬಿಡುತ್ತೆ ಈಗ. ಓಕೆ, ನಾವು see here ln K2 minus ln K1, it is written as ln K2 divided by K1. K2 divided by K1. Like the way it is present in the form of log A minus log B. It is present in the form of log A minus log B. Okay, log A minus log B is written as log A by B. Log A by B. A formula apply ಮಾಡ್ತೆ. It is equal to, okay, it is equal to this ekade ತಗೊಂಡ್ರೆ plus EA divided by R into T1 minus EA divided by R into T2. Okay, which is common here? Which is the common thing? EA divided by R, EA divided by R. It is common here. Therefore, ln K2 divided by K1 is equal to EA divided by R. अगर उಳಿತಿರಲ್ಲ EA divided by R ಔಷಧ ತಗೊಂಡ್ರೆ ಏನು ಉಳಿತು? 1 divided by T1 minus 1 divided by T2. Okay, then common is ಔಷಧ ತಗೊಂಡ್ರೆ here ln K2 divided by K1 is equal to K2 divided by K1 is equal to EA divided by R. Take LCM here. LCM ತಗೊಂಡ್ರೆ ಏನಾಗ್ತದೆ? T2 into T1 divided by T1. Wait. Sorry. T2 minus T1 divided by T1 into T2. This is the formula. Okay. Now I want to change ln to the log. What do I have here? Ln K2 divided by K1 is equal to EA divided by R into T2 minus T1 divided by T1 into T2. Okay. Here we have to change this ln into the log. Take that. Log of K2 divided by K1 is equal to EA divided by 2.303 into R into T2 minus T1 divided by T1 into T2. It is our simplified Arrhenius equation. First equation is ಇದು ಒಂದು ಅದನ್ನ ಸಿಂಪ್ಲಿಫೈ ಮಾಡಿದ್ರೆ ಈ ರೀತಿ ಬರ್ತದೆ ಎರಡು ಒಂದೇ ಓಕೆ ನಮ್ಮ ಕ್ಯಾಲ್ಕುಲೇಷನ್ ಈಸಿ ಆಗಿರುತ್ತೆ ನಾವು ಈಸಿ ಮಾಡ್ಬೋದು ಎರಡು ಒಂದೇ equation ಎರಡು ಬೇರೆ ಬೇರೆ ಇರಲ್ಲ okay here we want to discuss one more point here that is graph okay consider the equation number 2 here. This equation number 2 is in the form of y is equal to mx plus c. Is it? Here ln k is taken in the y-axis. Under y-axis we ln k togolli. And which is constant here? EA divided by R. It is constant. Here m represents EA divided by R. And which is the variable? X is the variable here. X is variable. As this variable changes, ln k also changes. It means in the reaction in this coordinate, take 1 divided by T. 1 divided by C. Then this ln A is constant. As a constant of the okay. Now this is straight line equation. Therefore, we will get what? A straight line in the graph. Straight line in the graph. Here, if we extend this one, you will get the intercept here. You will get what? Intercept. You will get the intercept here. That intercept is nothing but the constant ln A. Ln A. Okay, here you will get the slope. Slope of that angle is equal to minus EA divided by R. This is the graph for that equation. Okay, this much is about the Arrhenius equation. You problem solve ಮಾಡಕ್ಕೆ ಈ ಫಾರ್ಮುಲಾ ಯೂಸ್ ಮಾಡಬೇಕಂದ್ರೆ ನೀವು ಹೌದಾ T1 T2 ಕೊಡ್ತಾನ K1 K2 ಕೊಟ್ಟಿರ್ತಾನ ಮತ್ತು ಆಕ್ಟಿವೇಷನ್ ಎನರ್ಜಿ ಸಾಲ್ವ್ ಮಾಡಕ್ಕೆ ಹೇಳ್ತಾನ ಅಥವಾ ಯಾವುದೋ ಒಂದು ಟರ್ಮ್ ನ ಇದರೊಳಗೆ ಗ್ಯಾಪ್ ಬಿಡ್ತಾನ ಅದನ್ನ ನೀವು ಫೈಂಡ್ ಔಟ್ ಮಾಡಬೇಕು. It is very simple one. Okay, this much is about Arrhenius equation.